Let's dive into our roadmap for today. We'll start with biology and navigating conceptual traps. Then, chemistry, focusing on rules and exceptions. After that, physics, dealing with formulas under pressure, followed by English and logic hurdles. Finally, we'll wrap up with winning test day strategies.
All right, let's kick things off with Section 1, Biology, where we navigate those tricky conceptual traps.
Okay, listen closely. A DNA molecule contains 30% adenine. The percentage of cytosine is A, 20%, B, 30%, C, 40%, D, 70%. Now, don't shout out the answer just yet. This is definitely categorized as a very hard question on the MCAT difficulty scale. Why? Because the immediate misconception, the absolute biggest trap here, is looking at that 30%, subtracting it from 100%, and guessing 70%. The test makers are practically begging you to pick option D right there, because they know you're rushing.
To actually solve this, we have to pull up a core concept, Chargaff's rule. This foundational theory dictates that in a double-stranded DNA molecule, the base pairs always match up in a very specific way. The equation you need is simple. Adenine always equals thymine, so A equals T, and guanine always equals cytosine, so G equals C.
Let's analyze our options using this rule. If we have 30% adenine, we must also have 30% thymine. Together, that accounts for 60% of the entire DNA molecule. That leaves exactly 40% remaining for our other two bases. Since guanine and cytosine must be equal, we divide that remaining 40% right in half. That leaves 20% guanine and 20% cytosine. So option D's 70% is out. Option C's 40% is the combined total, not the individual amount, so that's wrong. Option B's 30% is a distractor for thiamine. The correct answer, without a doubt, is A, 20%. Now, before we move on, here's a similar practice question for you to think about later. If a DNA molecule contains 15% guanine, what is the percentage of thiamine? Write that down and try it out.
Moving right along to another very hard biology trap. If both parents have genotype AAB, what is the probability of obtaining AABB? A, 1/4, B, 1/8, C, 1/16, D, 3/16. Again, hold your final answer for a second. The common trap here isn't the math itself, it's time management. Students will literally waste 3 precious minutes drawing out a massive 4x4 Punnett square in the margins. You just can't afford to do that.
The theory required here is knowing standard Mendelian dihybrid cross ratios by heart. When you cross two heterozygotes, AABB times AABB, the phenotypic ratio is always 9:3 to 3:1. That's 16 total possible combinations. The genotype AABB represents the fully recessive outcome for both traits. Out of all 16 possibilities, there is only one single outcome where both recessive alleles align. So looking at our options, A, B, and D are incorrect ratios for this specific cross. The correct answer is option C, 1/16. To test your pattern recognition later, try this practice question. What is the probability of obtaining the genotype AABB from the exact same cross? Don't draw the box, use the patterns.
All right, let's pivot to chemistry, rules, and exceptions.
Here is a classic. The oxidation number of chromium in K2Cr2O7 is A plus 3, B plus 4, C plus 6, D plus 7. I'd rate this as a hard to very hard MDCAT question because calculation errors run rampant here. The biggest student misconception is forgetting to account for the subscript numbers. They'll just look at potassium being +1 and oxygen being -2, completely ignore the 2 and the 7, and totally botch the math.
Let's apply the correct theory step by step. The rule is that the sum of all oxidation numbers in a neutral molecule must equal 0. Step 1. Potassium is in group 1, so it's +1. Times 2 atoms, that's +2. Step 2. Oxygen is almost always -2. Times 7 atoms, that's -14. Step 3. We have +2 and -14, giving a net of -12. To balance this to 0, the 2 chromium atoms must contribute a total of +12. Step 4. Divide that +12 by the 2 chromium atoms, and you get +6. Let's analyze the options. A, B, and D are common results if you forget to multiply or divide by the subscripts. Therefore, the correct answer is definitely option C, +6. For your study session later, try finding the oxidation number of sulfur and H2SO4 using this exact same methodical process.
Now for a conceptual chemistry hurdle. Which compound exhibits hydrogen bonding? A, CH4, B, NH3, C, CO2, D, CCl4. I'll give you a second. This is a moderate to hard question, but it trips up so many people. The trap? Seeing the letter H in an option, like in CH4, and immediately assuming it forms hydrogen bonds. But that's a huge misconception.
The theory here is strict. For a molecule to exhibit true hydrogen bonding, a hydrogen atom must be covalently bonded directly to a highly electronegative atom, specifically fluorine, oxygen, or nitrogen. Just remember the acronym FON. Let's eliminate our options. Options A, C, and D, methane, carbon dioxide, and carbon tetrachloride, all lack FO or N. Carbon just isn't electronegative enough, so these only exhibit weak London dispersion forces. But look at option B, ammonia. NH3 features a direct bond between nitrogen and hydrogen, creating that intense dipole. So, option B is the correct answer. A great practice question to follow up with would be, which has a higher boiling point, H2O or H2S, and why?
Moving right along to physics, formulas under pressure. This section is all about keeping your cool.
Try this one out. If the frequency of a wave doubles while its speed remains constant, its wavelength becomes A double, B half, C 4 times, D unchanged. This is a solid, very hard question because of a massive psychological trap. Human intuition often leads us to think in direct proportions. Our brain says, hey, if one thing doubles, the other must double too, which leads students straight into picking option A.
Let's dismantle that intuition using the actual physics equation. Velocity equals frequency times wavelength, or V equals F lambda. The core concept here is understanding inverse relationships. The question explicitly states that the speed, v, remains constant. Because frequency and wavelength multiply together to equal that constant, they are inversely proportional. So analyzing the options, if you multiply the frequency by 2, you absolutely must multiply the wavelength by 1/2 to keep the equation balanced. Option A, C, and D violate this mathematical relationship. The correct answer has to be B, half. And here's a spin-off question for your notes. If the wavelength of a wave triples while frequency is constant, what happens to its speed?
Enter our final subject block, English and logic hurdles. Do not sleep on these. They test ultimate precision. Let's look at this English challenge. You need to complete the sentence starting with neither of the boys using either have or has. This is a hard difficulty grammar question. The trap is so sneaky here. Your ear hears the plural word boys right next to the verb, and your brain instantly wants to use the plural verb have. It's a classic proximity error.
Let's look at the grammatical theory. The phrase of the boys is just a prepositional phrase placed there specifically to distract you. The actual true subject of the sentence is the indefinite pronoun neither. And neither is strictly a singular subject. It means not one or the other. Because the subject is singular, subject-verb agreement rules dictate it requires the singular verb has. So, neither of the boys have completed is completely incorrect. The correct answer is text 2. Neither of the boys has completed. To lock this in, try this practice question later. Is it either of the girls is going or either of the girls are going?
Finally, let's test your logical reasoning. Find the next number in the series. 3, 7, 15, 31, 63. What comes next? A, 95, B, 127, C, 125, D, 129. This is a very hard logic puzzle. The misconception here is trying to rely solely on basic addition to find the gaps, like adding 4, then 8, then 16. While that technically works, calculating 63 plus 64 under extreme time pressure is exactly where sloppy addition mistakes happen, leading you right to a wrong option.
The core concept in MDCAT logic is finding the fastest mathematical formula, the hidden multiplier. The rule governing this series is n times 2 plus 1. Let's test it. 3 times 2 is 6, plus 1 is 7. 7 times 2 is 14, plus 1 is 15. It works perfectly every time. So looking at our final number, 63 times 2 gives us 126. Add 1, and we arrive precisely at 127. Looking at the options, A, C, and D don't fit the formula at all. Option B is the correct, mathematically sound answer. Want to challenge yourself? What would be the next number after 127 in this exact same sequence?
All right, we've tackled some seriously intense, high-level questions today. Let's head into our final section, winning test day strategies.
Everything we just discussed boils down to these 3 takeaways. First, master pattern recognition. Whether it's genetic ratios or number sequences, recognizing the framework saves you minutes. Second, trust your elimination techniques. Knowing strict rules, like FON for hydrogen bonding, lets you instantly wipe out wrong answers. And third, never let traps rush your calculations. take the literal 10 seconds to map out an equation like V equals F lambda, or write out oxidation steps before you guess.
I'll leave you with this provocative thought. As you prepare for the 2026 MDCAT, are you just memorizing disconnected facts, or are you actually ready to master the patterns? Because these very hard questions, they aren't testing what you've read, they're testing how you think under pressure. Shift your mindset, apply these techniques, and you will absolutely crush it. Thanks for tuning into this explainer, and until next time, keep studying smart.